Okay, first part in a series, parts of a compass. You have two types of compasses. You have the base plate and you have a lens static. Lens static, for example, would be the Kamingas that the military has. Personally, I prefer a base plate. Now, the parts to a base plate compass, you have your mirror, sight 1, sight 2, adjustable bezel, needle, grid lines, measurements on both sides, 1 to 25K and 1 to 50K, magnifying glass, and base plate. This does have adjustable declination. We'll get into that a little bit later. But that is the basic parts of a compass. Part 2, how to use a compass with bearing, reverse bearing, or azimuth, and declination. On this compass here, excuse me, on most modern compasses, you'll have a red needle, a red doghouse. Most of the time, the south needle is painted black. On this one, it's white. So, I want to make sure I'm at 360 degrees. 360 is 0. And I want to put red in the shed. So I'll move the compass right there. This direction, we'll just do a line. This direction from this location is north. That means this is south, this is east, and this is west. Because the red is in the shed or the dog is in the doghouse. Declination. You have true north. So you'd have true north, which points to the actual Earth axis. You have grid north on a map, and it points to how the map is shaped. We'll get into that. Then you have magnetic north. Magnetic north is what this points to. And every year that changes. Right here at my location, I'm at 6.32 to 7 degrees. So I adjust for that on this one. Right here, you'll notice that's a little off. If you look at true north, or true north would be about right there. That's the declination. So that's 7, we'll just say 7 degrees west bearing. And what that is every degree is broken down in time. So I could be off by an hour, I could be off by 7 hours if I don't know my declination. That's why it's important. Now, so you have an azimuth. Say my azimuth is true. Say I'm going to put it normal. So I'm at 360 degrees or 0 degree azimuth. My back azimuth or reverse azimuth is 180. If you are using a lens static, remember LAMS. It's an acronym for the military. If it's less than 100, if your bearing or degree is less than 180, you add 180. If it's more than 180, then you subtract 180. And that'll give you your reverse azimuth. Okay, everybody tracking? Okay, map use. The way you orientate a map, I'm going to set my compass to 0 degrees. I'm going to put it in the bottom left corner of the map. Now, I am going to rotate the map, not the compass. I'm going to rotate the whole map until red is in the shed or the doghouse is in the doghouse. Okay. So right now my map is oriented to magnetic north. Little bit of tips. You want this on a flat surface. You don't want any metal. You don't want it to be wet. As in, you put your map on a wet ground. You want it to be flat. No metal within about 5 meters, depends on what it is. Okay, I had this map especially made by mytopo.com. I am not affiliated with them. I do not get paid, but they make custom topographical maps. This map is set to a scale of 1 to 10,000. Maps come in scales. You can get them made to 1 to 1,000, 1 to 100,000. I'm going to show you different maps. The less number, in other words, this is 1 to 10,000, will have more detail than a map that's 1 to 100,000. Put that in perspective. You notice I didn't mention feet or meters. Most maps nowadays are made in meter or the metric system increments. Okay, but let's talk about scale. An inch on this map would be equal to 10,000 inches in real life. A meter would be equal to 10,000 meters. A foot would be equal to 10,000 feet. You understand that? Okay, now let's plot a bearing. I'm going to pick a spot at random. So, let me see what you can see. Okay, say we want to go from this intersection, okay, down to, let's not make it too easy, down to right here on this MSR. Okay, I know my two intersections, and we'll do this on with some pencil and stuff too. And I want to go to right here. Okay, so this is my start point. This is my finish up point. That is really important. You do not want to get those messed up. If you're plotting a hunt, if you're plotting a hike, you go point to point and you don't get them reversed. Okay? Now, best thing about an adjustable bezel ring, I'll put red in the shed. My bearing is 310 degrees. I'm just showing you. Red in the shed. That's what that is, actually, right there. So about 312 degrees from point A to point B. The reverse of that, well, on these, all I got to do is look at the south-facing needle. My needle reads about 170, 168. So I have a reverse azimuth, which is how I get back to point A, and I have my bearing or my azimuth. Azimuth and bearing can be changed with each other. It's different words saying the same thing for the most part. 99.9999% of bearing and an azimuth is the same thing. Notice I said degrees. I did not say mils. You want mils? Go to artillery school. Land navigation for your civilians are done in degrees. So, now that we know how to plot a bearing, we're going to get into maps and different types of maps, how to do things, what to look for, terrain features. It's going to be fun. Before we go any farther, you're doing great. Let's talk about pace. Mille paces means 1,000 paces. Everywhere the Roman army went, they put a mark up at every 1,000 paces. It's where we get the name mile, milli, mile. Your pace count is how many paces does it take to get you to move 100 meters. Everything affects your pace count. The wind, the weather, if you're tired, if you're going uphill, downhill, if you're wearing boots versus sandals, if you're barefoot, if it's muddy, if it's a rolling terrain, all that affects your paces. So what you do is you measure out 100 meters exactly. In the military, you count your pace on your right foot because we're taught to always step off on your left foot. Personally, when I came out, I broke that teaching. For some reason, I started to step off on my right foot. So I count my paces on my left. So as long as you count them on whichever foot that you did not step off with, you should be golden. Here's a set of pacing beads or ranger beads. This can be, you bend down and you pick up a stone every 100 meters. If you don't have a set, you take a piece of cord, you tie a knot in it. You take and make a tick mark in a notebook every 100 meters. Or every time you count to your pace, say, whatever your pace count is. Once you move 100 meters, you take one of these beads or knot and you move them down. Your next 100 meters, you move them down. Your next 100 meters, you move it down, so on and so forth. When they're all down, you move one of these down and move these back up. Okay? And then you start moving this down. So this right here means I've moved one click 100 paces or 1,100 meters. This would be 2 clicks, 3 clicks, 4 clicks, move them up, start again. That's what a pace is. Now, to show you the difference in scales, there's maps that I prefer. And the maps that I prefer are the Dillon, Atlas, and Gazetteer. It's going to have back roads, recreation sites, GPS grids, family outings, boat ramps, campgrounds, places to explore. It's got your game lands, your fishing lands, all of it. So this is at 1 in 160,000. To show you that in perspective, this right here, gentlemen, is my happy hunting grounds. All through here. Okay. Shining Rock Wilderness. This is my happy hunting grounds. This is where I camp, I hunt a lot, I trap. This area right here. Okay. I happen to have a National Geographic topographic trails illustrated map. This is the other type of map that I prefer. This is 1 to 50,000. Let me make sure that I'm on the right side here. Okay. Yeah. Shining Rock Wilderness. You see how much more of a detail I get? Okay, so now that we know what that is, and then just as an example, here's one that's 250,000. Now take it back. This is one that's, which one is this? Which one did I grab? Dun, 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 dun. No, this is one in 50,000. Okay. That's going to show you the different types of detail you get on your maps. Now, I want to show you how I plot a course. So you have different types of grids. You have UTM grids. These are military UTM plotters. I'm going to show you how that works. What you do, you pick your plotter, whichever one you like, it doesn't matter. We'll just use this one. Okay, they come in rounds. It's all basically the same thing. Now, if you can read your plotter, it's facing the right direction. This is backwards. I can read it. So I'm going to use this scale right here, 1 to 50,000, and I'm going to come down. I'm going to see if I can zoom in. Okay. So right here at this square, if someone gives me the coordinates, right, to this square, I'm going to put my plotter here because you read left to right and then north or south to north. So I'm going to go over, say they give me 9-4. I'm going to move over to 9, which would be right there. Now I'm going to go up 4, so I'm going to be right here in Daniels Cove. See if I can get a pencil. Okay. So again, I don't do this one. I'll move over to 9. I'll go up 4. So that's going to be my first one. Okay, and then say I want to go from here, I want to go to the parking lot, which is right here. Okay, so I can take this, I'm going to put that right on that dot, and I'm going to take some string, you can use the inside of a paracord. So where am I going? I'm going to the parking lot. So I'm going to make sure that's on my dot right here. And I'm going to pull it over. And it's going to be about right there. So I'm going to say about 70 degrees. Okay, so we have 7 degrees. I'm just going to write that down on something. Or 70 degrees. I'm going to pull my compass out. I'm going to line up from that dot to that parking area. I'm going to put red in the shed. Okay. As long as I have red in the shed. You can see this a little bit better than I can. Okay, red in the shed. Okay, so my bearing's gonna be 140, or 160 is my bearing. You see how you can be off that way? Now what that probably was the thickness of the 550 cord. Okay, so if I give you coordinates of like say 82 to, let's see here. I know it's gonna be on the 82 range. And we're gonna go up to, say, 39. So I'm gonna look down here at the bottom of my map. Okay. There's gonna be 82. Right here. 82. And I'm gonna move up to 39. So right here. So this has got it down to about 50,000, or say about let's say about 100 square meters. I'm gonna grab my plotter here. You see how that just affects that? And then I can make it narrower. I can take it down to 100, to 10 meters, to 1 meter. That's how you do that. We'll go more in depth on this. I just wanted to introduce it to you. Now, let's look at the terrain features. And I have a map just for that, okay? You're doing great. Again, right here, my happy hunting ground. You have Sam's Knob, then you have Little Sam's Knob. Okay, I'm just making sure you can see that. If you look at the interval between okay, right here. For those of you that don't know how to read a topo map, we will get through this. It's not hard. You have a peak right here. Then you have an interval right here. Shows you how steep it is. The closer they are, the steeper the terrain. Right here you have another hill, or another peak, Little Sam's Knob. From here to here, this is a saddle or a valley. Okay? This is a gradual progression. This is a steep progression, almost a cliff. You have your creeks, the flat laurel. So what I basically do is from this parking lot, I'll walk down this trail. This dotted line right here is a trail. Great meditation areas. This right here, if you look, since this is a known parking lot, it's going to give you coordinates on these maps. This is a field, and it's a gradual down to the slope. You can look on how they're going out. If this was going this way, it'd be climbing it, okay? So this is a field down to the flat Laurel Creek. These two trails intersect. One goes this way, continues on to Devil's Courthouse. And there is this trail right here, which is an old logging road that goes out to Graveyard Fields. Okay? But the area that we're interested in is this area. So when you look at the intervals, you can see that I have a hill here. I have pretty much an even way up till I get to about right here, and then I start climbing. I go downhill here, and then this area kind of opens up into a flat area with a little bit of hills on this side. Now, in person, we will get more detailed into that. So, once you have your map oriented, which this map is not oriented at the moment, you can do your distance. The way I personally do distance is if you take a straight line and you go from here to here, that's as the crow flies. From here to here. That's how the crow flies. Or say from this point of the trail to this point of the trail. Okay, that's not going to tell you the correct distance. You take you a piece of paracord or whatever it is you got laying around, and you try to draw that map or that trail the way it is. So you take that, and then you'll stretch it out and put it on your scale, on your distance scale for your map, and then you know. Okay? So make sure you do that. Don't just measure straight across, because that's not going to be accurate on distance. That's going to be straight line distance, not the distance of the trail. Okay? Now, let's look for terrain features. We know we have an MSR down here. That's another name for a road. We have an ASR right here. That's going to lead us down to this. That's another name for a road. We have a gravel road that comes down through here. Now we have options. Okay. We do have a water source. We have grazing areas. We have cover. Do we have a handrail? What a handrail is something that I can keep to one side or the other and move with it. Yes, we do. We're going to get into these terms, by the way. This would be my handrail, this creek. Once I take here and I take this trail down to this creek, I can choose to walk with the flow of the creek on my right-hand side, going down until I eventually get to this. This is my backstop. This MSR right here or ASR right here is my backstop. That means if I get to that backstop, if I get to that road, I've went too far. See, so this from here, right here to right here, I have a handrail. The trail keeps moving this way. If I continue and I get to this road, that's my backstop. That tells me I've went too far. Okay? So a handrail is something that, it could be a pipeline, it could be a road, something that I can walk beside and know that I'm walking in the direction that I need to be walking in. A backstop is if you reach this backstop, if I'm coming through here and I come across this road, well then I've went too far. It could also be the parking lot. It could be another stream. Okay? So that's a backstop, that's a handrail. Let's look at a panic azimuth. So I have my bearing, and I'm walking from Little Sam's Knob right here to Sam's Knob right here. Okay, I'm going down, and so I get lost about right here. Okay, my panic azimuth would be, I'm going to have wrote down my reverse azimuth, or an azimuth that's going to take me to a known location. But most of the time it's a reverse azimuth. Okay? Now let's talk about, by the way, I forgot, but you're doing great. I'm so proud of you. Let's talk about backstops, handrails, baselines, aiming off, and blazing. Okay? So I'm going up to Little Sam's Knob. I'm going to use Flat Laurel Creek as my handrail. I know I can follow it for the majority of the trail and not get lost. A backstop is this right here, like what we talked about. If I reach this point, then I've went too far, and I need to turn around, get my reverse azimuth, and then come back. Okay? Baseline. Your baselines help you stop lateral drift. Which, okay, for example, on this compass. On my compass, I'm going to put red in the shed just for this example. So say I want to walk at 84 degrees. Okay, that's the bearing that I want to take. As long as this needle right here stays in the doghouse, I'm walking at that bearing. Okay. Let me just make sure it's still in there. Okay. I'm walking at that bearing. And that is in there, trust me. I'm looking at it just the way the camera is. If the needle goes that way or it goes that way, I'm not walking at that bearing. As long as that needle stays in the doghouse, I'm at that bearing. Okay? So, what lateral drift is, if you're right-handed, you will drift right. If you're left-handed, over distance, you will drift to the left. That's just how it is. With the compass, as long as that needle stays in the doghouse or red in the shed, you're walking in a straight line. Okay? So that's what a baseline is. My baseline is whatever degree bearing that I want to walk. And I'm keeping red in the shed. I'm keeping the dog in the doghouse. I'm not lateral drifting. Okay? Blazing. Blazing is you got to your campsite for the night and you want to look around. You want to walk out 100 paces. You want to explore what's around your area. So you leave a blaze orange piece of fabric up in the tree at your camp. As long as you move and you can still see that piece of fabric, that's a blaze. As long as you move or you don't move to where you can't see that blaze. If you intend on doing that, tie another blaze that's within sight of your first one. Explore around there. That is what blazing is. Blazing is marking your trail so you can Hansel and Gretel it back. Aiming off. Aiming off accounts. Say I want to go from point A to point B in a tactical situation. And the degree reference, my bearing, my azimuth, is 90 degrees. So I'm not going to walk straight to that point and it being a tactical situation. I'm going to aim off. I'm going to know the distance to my objective. Say it's 100 meters. I'm going to aim off by 10 degrees. So I'm either going to do my bearing to 100, and once I get to 100 paces and turn, or 100 meters and turn, I'm going to turn left. If I go to 80 degrees, notice I'm only going off by 10. Keeping it simple. I go to 80 degrees, I get to the known distance, I turn right. That is aiming off. Okay. Now, like I said, we're going to go more in depth on UTM grids, also called Universal Transverse Mercators. But we're going to keep it longitude and latitude. I'm also going to talk about some primitive methods. We're going to talk about moving around objects. It's going to be great. You're doing great. Welcome back. I'm going to show you topographical references that you need to know. You're doing great. Now, you have hilltops. this right here is a hilltop. Okay. So this right here itself is a hilltop. A series of hilltops, such as this right here, is a ridge. Okay, between each hilltop is a saddle. Okay, so we got saddle, ridges, hilltops, valleys. Most of the time, your water is going to be in a valley. But you see this right here? This right here is a cut. You see how it's making V shapes? And we have a stream. This stream is what I found the other day. This is also a small valley. Put that in perspective. Here, we have hollows, or if you're down south, hollers. We have hollers right here. And you see how this is not making a V-shaped end. So that's not a cut. Okay, that's a spur. These are spurs. This is a cut or a draw. We call them hollows, hollers, small valleys. On a topographical map, they'll be shaded for the most part. Your red areas, this is the town. This is where people live. This is urban development. Your factories, urban development. And these little black dots are individual homes. Okay? So, if we have something that is like this right here. This here is a prime example. You have a hilltop. On this side, it kind of flattens out a little bit, and then it gets real steep because the lines are closer together. Okay. That would be not a sheer cliff, but it's going to be pretty much up and down. You might be crawling in some areas. This is more sloped. It's more gentle. Now this here is an elevation. Every 5 lines on a topographical map, you'll have your elevation. This is at 3,000 feet. So determining what we'll look and see, I think it's 40 feet. Yeah, it's 40 feet intervals. So between this line and this line is 40 feet in elevation. 40 feet, 40 feet. Now right here, you see how it's real close? That'd pretty much be a 40-foot cliff straight up and down. Same way right here. Then it levels off, so that's 1, 2, 3, 4. So the top point right here would probably be close to 4,500 to 5,000 feet. Because we're doing 44 inches, so it'll be like 4,500. Okay. That is a topographical map. Then you have this area right here. Now, I know right here is an industrial area. You see these right here? See if I can swing in on them, and I can't. Well, wait a minute. This right here is a railway. Okay, that's a railway. It keeps going. Right here's where it goes over or under a bridge. Again, in person, if you need, contact me and we will go over this until you understand it. And I don't mean that in any type of slot. Sometimes this is a lot of information to give, but I want you to know you're doing great. UTM coordinates. Most of the time will come in an 8-digit coordinate. What you do, first thing you do You put a line down the middle. Okay. You start with your first two, and that's going to give you your grid section. These two will give you where in that grid. Make sense? Now, I have crudely, if I say so myself, drawn out grid coordinates. Now, you always go, sorry about that, you always go left to right, then south to north. So our grid coordinates was 84, 32. And that's going to put me in, I go up to 32. Okay, so right here, that's going to put me in this box. Okay. Now, say I didn't have a protractor. I'm going to divide this box into tens. 1, 2, 3, 4, 5, 6, and so on. Same way through here. So, if we look at our coordinates, 84, 50, 32, 60. I'm going to go 84, 32. I'm going to come over to 5, which will put me somewhere here. I'm going to go up 6. Well, it's going to be just past the point spot. So I'm going to put me about right here. And that's all there is to it. So 8450 to 3260 is your UTM grid coordinates. Without a protractor, I'm going to guesstimate it's about right there. You take your grid square, divide it into tenths on both sides, and you read left to right, south to north. You follow what I'm saying? That is UTM grids. Now, you're doing great. This is how you navigate around an obstacle. Say Larry is beak bopping through the woods, comes across a lake. His bearing is 90 degrees. What old Larry's going to do is he's going to drop that bearing to 180. Walk down to the end of the obstacle, go back to 90 degrees until he clears said obstacle, switch back up to 360 degrees until he's on the same area, then go back to 90. Now let's add a little bit more detail in that. From here to here, say Larry's pace count is 1,100 paces. This to here doesn't matter. But what does matter is when he gets to this right here, his pace count needs to be 1,100 paces. Then he switches to 90 degrees. You follow? And that's all it is. Navigating around an obstacle, whatever your bearing is, 180, 90 degrees. And that's all I'm doing is I'm adding 90. 90, 90, 180. Subtract 90, 90. Okay, well, I got to go back. I got to go back up. So that's 360. Now that's the opposite of 180. My pace count, 90 degrees again, I'm golden. Well, Larry's golden. I hope you have enjoyed this little course. I will go into more detail in the future in person. If you have a comment, a question, message me and I will work with you until you conquer land navigation.